Hey, welcome back again. We stopped at where we are looking at angular velocity and we got it to be 2 pi f. We agreed others can represent it as omega is equals to 2 pi over t. Others can represent it as v over r. Now, in this case, we are going to continue because our main topic was centripetal acceleration. And if you remember from linear velocity, you realize that linear acceleration, that is a, is equals to the change in velocity divided by change in time. Change in velocity divided by change in time. Now, let me take you back again. For those who are drawing those linear motion graphs, you remember that if you draw a graph of v against t, that is a graph of velocity against time, velocity on the y-axis, time on the x-axis, and you find the gradient, you'll get the gradient to be in meters per square second, and that is acceleration. And in this case, we're going to find our centripetal acceleration as AC is equals to the phi over t. Now, I'm assuming there's a very big change, that is phi over t. Now, let's go back to our angular velocity. Our angular velocity was omega is equals to v over r. Now, make v the subject. Make v the subject. If you make phi the subject, v will be equals to omega r. Now, let's represent it here. Replace it here. If you replace it there, it will be a subscript c is equals to omega r over t. Omega r over t. And omega r over t, it is a, it will be a subscript c is equals to omega r over t. Now, I want us to see this r over t. R over t is the same as v, because r is just the distance, you divide by t, it is v. So that's another velocity. So our AC will be equals to mv over m, that is AC is equals to omega v, and that's what has been calculated here, that AC is equals to omega r over t, and the r over t is v. That's what I've represented here. If you can see it here, r over t is equals to v. Now, I was replacing it, and I got as centripetal acceleration is equals to omega v. Omega v. Now, that's one way. Another way, also somebody can represent it as now you replacing omega with phi over r in Roman 1, you realize that it will be AC is equals to v dot v, you divide by r, and that is equals to phi squared over r. So another way of representing centripetal acceleration is v squared over r. Now, I started from change in velocity divided by change in time. What I wanted to make is just to make everything easy. There are many ways. Many people will just use the change, and then they will be integrating and differentiating, because there are ways you can find it. So this is the simplest way. And in our case, what we need is just to see how things are flowing. And here we've gotten as a to be equals to v squared over r, and that is what is so important in this case. Whatever I've circled here, it will be so important in this case. So that's what we'll be using all through. And I like us to see an example. The example presented here is a small object moving in a horizontal circle of radius 0.2 meter makes 8 revolutions per second. Determine it is centripetal acceleration. Now, if you can remember the last video, we were defining some terms. I defined frequency and period. And if you can remember, I said period is the time taken by a body to make one complete revolution. So that is period. It is the time taken by a body to make one complete revolution. And frequency is the number of revolutions made by a body that is moving round a curve per second. So the number of revolutions per second is our frequency. Now in our case here, what we have is we have a radius of 0.2 meters. We have the radius to be 0.2 meters. And our frequency, we are using the lower case of f, that is the small f, which is 8, that is revolutions per second. Just write 8 revolutions per second. And now to determine its centripetal force, what we do here it is, we apply the formula that we've shown here, that our formula, it is here, that AC is equals to V squared over R. That's what we're going to use, that AC is equals to V squared over R. That's what we're going to use here, and that's what I'm applying. And I've realized that AC is equals to V squared over R. Also, here, what I've done actually, if I come back here, I've represented, I got it as AC is equals to V squared over R, and I remember our omega was V over R. Now, if I cross multiply through this formula of omega is equals to V over R, then my V will be omega R. Now, V squared, if I square it, I'll get, if I square it here, I'll get omega squared R. What I'm saying is that my AC is equals to V squared over R, but my V is equals to omega R, because omega here, it is just V over R. Now I want to replace my V here. I want to replace my V there, so that I'll get AC, it will be V squared, and here we have omega R is our V. So if I square the two terms, that is omega and R, then I'll get this formula that I've used here, that R is equals to omega R omega squared. But omega, we derived it here, our omega, we derived it here, that omega is equals to 2 pi f. I want to use this one here, that 2 pi f, I want to use it here in this case. So what I'll get first in my solution, in my example here, that's my challenge now, my problem here. What I'll do, I'll find omega by using the formula 2 pi f. Then I'll get it as, because I also said that our frequency is 8. Now 2 pi, you multiply the frequency, which is 8, then I'll get omega. So omega will be 16 pi. Now, let's also go back to our AC. AC, the formula is here. So AC is V squared over R, or we can use this one because it has omega. So it will be R omega squared. And in our example, we are given our radius to be 0.2 meters. So that's our radius. And we've also calculated omega. We've gotten omega to be 16 pi. Now, our AC will be 0.2. You multiply by 16 pi, then you square the 2, and then you'll get 51.2 pi squared. So somebody also can represent it as 51.2 multiplied by pi squared. You'll get, I'm also getting 505, that is 505.32. So somebody also represent it that way, that omega is that is centripetal acceleration, sorry, that centripetal acceleration, that is A subscript C, will be 505 0.32. So in other words, we'll be moving with this formula all through. AC is equals to V squared over R, where AC is our centripetal acceleration, V is our velocity. And remember the difference between this velocity we are talking about, it is the linear velocity. And I think when we are going to the next video, I'll show you the difference between the linear velocity and the angular velocity. So our V is our linear velocity. You square it, you divide it by the radius. The radius you'll be given, or you can calculate using the relations from omega, that is V over R. You can also find it given the velocity and centripetal acceleration. So that is the one example I got. So if there's any question again under the centripetal acceleration, you are welcome and feel free to ask. We are there for you guys, and we are fighting that every individual gets this information. Be blessed, and may God bless you. Thank you.